It's the year 2026. Commercial aviation has evolved in many ways. Flights have become more efficient, more connected, and no doubt more accessible than ever before. But speed remains largely unchanged. Crossing continents still takes the better part of a day. The longest flight in operation, from Singapore to New York City, stretches across nearly half the planet and keeps passengers in the air for close to 19 hours. And yet, on that very same route, the journey wouldn't need to take that long. If the Concorde were still flying, the total travel time could drop to just 7 to 8 hours, less than half of what it is today. There was a time when flying faster than sound wasn't an ambition, but a working reality. The Concorde made that reality possible. It redefined long-haul travel, cutting transatlantic flight times dramatically. But in 2003, the Concorde made its final flight, bringing an end to supersonic passenger travel. The challenge wasn't just cost, it was noise. The sonic boom, powerful enough to disrupt communities on the ground, made supersonic flight over land impractical. Without the ability to operate across global routes, the economics simply didn't hold. And so, for more than 2 decades, the world returned to subsonic speeds, leaving the promise of supersonic travel just out of reach. Today, that may be about to change. NASA's X-59 is not built to carry passengers but built to solve that problem that ended supersonic travel in the first place. When an aircraft crosses the speed of sound, it creates a shockwave known as a sonic boom that can be heard and felt on the ground. Regulations around the world restrict this, which is why modern jets stay subsonic over land. If videos like this fascinate you, make sure to subscribe to the channel. We dive deep into in-depth aviation stories. The X-59 approaches the problem from a completely different angle. Instead of trying to deal with the sonic boom after it happens, the aircraft is designed so that the boom never forms in the same way to begin with. Its shape is unusually long and narrow, with a stretched nose and carefully distributed surfaces. Every part of the aircraft is positioned with one goal in mind, controlling how air pressure builds up as it moves faster than sound. In a typical supersonic aircraft, shockwaves from different parts of the plane merge together as they travel downward. By the time they reach the ground, they combine into a single powerful pressure change that leads to the classic sonic boom, which is impossible to ignore. The X-59 here breaks this pattern. Its design spreads those shockwaves out. Instead of merging into one sharp hit, they remain separated and weaker. What reaches the ground is no longer an explosive crack, but a softer sequence of pressure changes, something closer to a distant thump than a disruptive blast. It's a subtle difference in sound, but a massive difference in impact. Because the real limitation on supersonic travel has never been whether we can fly that fast. We've already done that. The limitation has been whether people on the ground are willing to accept it. Regulations were built around that loud, window-rattling boom. Entire countries restrict supersonic flight over land because of it. So if the noise changes, everything else can change with it. Routes that were once impossible suddenly become viable. Supersonic flight is no longer limited to oceans. Airlines can begin to think differently about speed again, not as a luxury experiment, but as something practical. And that's why the X-59 matters. NASA plans to fly it over select communities to gather real-world data on how people perceive this reduced noise. These results will be used to help regulators reconsider current restrictions on supersonic flight over land. If those rules change, the impact could be significant. Airlines could operate supersonic routes across continents, not just oceans. Travel times could drop dramatically. A flight that takes 10 hours today could be cut nearly in half. Business travel, global connectivity, even how cities interact with each other, everything begins to shift. In 2026, it's about solving the limitations that came before. The X-59 represents a test, not just of technology, but of whether supersonic travel can finally fit into the modern world. And if it succeeds, the next decade may not just improve air travel. It may redefine how fast the world can move. Personally, I'd love to witness a moment like that. Standing there and seeing it pass overhead, knowing it's crossing continents in just hours, that's the kind of shift aviation has been missing. Thanks for watching, and as always, see you on the next flight.